Okay, this is our lecture for Math 1302 Intermediate Algebra at LCU. This is our Tuesday, November 3rd lecture since I'm going to be out of town. What we're going to look at today, I started on it in our lecture today on parallel and perpendicular lines in the text, Chapter 3, Section 6. And I'm going to work 8 examples, and before I do that, I'm going to repeat briefly what I told everybody in class today. We want to look at the equation of two lines and know if those equations are parallel. Parallel lines look like this. If you draw the graphs, they would never intersect. They run in the same slope, direction as each other. Perpendicular lines meet to form a right angle. And there's an easy way to tell by looking at the equation of a line if those two lines are parallel or perpendicular. And let me show you what that is. If the lines are parallel, let's say this is the equation for line 1, this is the equation for line 2. If line 1 is parallel to line 2, then the slope of line 1 is equal to the slope of line 2. So if you have an equation for this line and you have an equation for this line, in common language, the way you tell if the lines are parallel, are their slopes equal? Are they the same thing? Some examples, if you had, if slope 1 was 2/3, and if slope 2 was 2/3, those two slopes are equal, so those lines are parallel. If this is anything except for 2/3, they're not parallel. What about perpendicular lines? Well, if line 1 is perpendicular to line 2, then the relationship between their slopes, this is going to look meaningless. It won't mean a lot when you look at it. It'll sound meaningless, but when I show you an example, it's very easy. It's easier to apply it and use it than it is to write the rule. But if two lines are perpendicular, the slope of line 1 will be equal to the negative reciprocal of line 2. The slope of one line will be the negative reciprocal of the other line, the slope of the other line. Now, I know that that's nearly meaningless. Now, I would encourage you, maybe if you're writing things down, to get it down or put it in your notes, just like you would if we were in class. Pause the video and copy that down, because I'm going to erase it and show you an example. When I show you an example, it'll be very easy. What does it mean for a slope to be the negative reciprocal of another? Watch this. If the slope of line 1 is equal to 2/3, and if the slope of line 2 is perpendicular, if line 2 is perpendicular to line 1, the negative reciprocal is this. Flip that fraction upside down and change the sign of it. So if it's positive 2/3 here, it would be negative 3/2. That's the negative reciprocal. Isn't that easy? 2/3, if this slope is negative 3/2, then they're perpendicular lines. Let me do another one or two. What if the slope of one is negative 7/5? What would the slope of a line that's perpendicular to that be? Flip it upside down and change the sign and be positive 5/7. So it's effortless. It doesn't take any effort at all, as long as you know the relationship. Let me show you another one or two. What if the slope of one line is 3? What would the slope of a line that's perpendicular to that be? Well, think of 3 as being a fraction. 3/1. What do you get if you flip that upside down and change the sign? Negative 1/3. So let's do some problems using these two properties. I'm going to start with problem 14, which is just a classic type problem that you do on these. And I'm going to skip some of the shorter, quicker, easier ones because often my students, it just doesn't register the relationship between the slopes and the lines at first. And after we do a few of the standard problems, I find it's easier to go back and then do the easier, quicker problems. Let's start with number 14. On 14, we're given two lines. So line 1 would be this one. Y is equal to negative 2x plus 2/3. line 2 is this one. Y equals negative 2x plus 3. And what we want to know, are those two lines parallel or perpendicular or neither? Well, look at the slope. Now, I'm assuming that you remember that if an equation is written in this form, y equals mx plus b, that's what we call the slope-intercept equation of a line. M is always the variable that represents the slope, and b is usually the variable that represents the y-intercept of a line. And so when I look at this equation, the slope of this line is negative 2. Slope 2, because it's line 2, is negative 2. The slope of this equation, slope 1 of line 1, is negative 2. They're the same number, they're equal, so the two lines are parallel. And that's because this equation was written in slope-intercept form, and it made it easy to just look at it and give the answer. Now, so the answer to the question, if you're given these two lines, these lines are parallel, you can say it like this: line 1 is parallel to line 2, and that'd be a great way to write your answer. Let me ask you something just out of curiosity. What if I added an additional question? Now, this is not in the text, but what if we asked it, if line 3 is perpendicular to line 1, what is the slope of line 3? If I tell you I have a line that's perpendicular to line 1, what would its slope be? And you just smile and grin and say, you silly goose, it's the negative reciprocal of negative 2. So think of negative 2 as a fraction, 2 over 1. Flip it upside down and change the sign, so positive 1/2. Any line that's parallel, that's perpendicular to line 1 will have a slope of 1/2. Now that wasn't in the book, but some other question that you'll do for homework might well ask that kind of question. Okay, let's do number 16. Again, we're given two equations. I'm just going to call the first one line 1, the second one line 2. And the question that's asked is, are these lines perpendicular? There's the graph of line 1 perpendicular to line 2. Well, look at the slope of line 1. If a line is perpendicular to line 2, if L is perpendicular, I'll say it like this. If L is perpendicular to line 1, then what do you know about the slope of line L? It has to be the negative reciprocal. It would be negative 2. Well, look at the slope of line 2. It's not negative 2. It's negative 1/2. So these lines are not perpendicular. And by the way, because this slope is positive 1/2 and this slope is negative 1/2, they're not parallel either. And all that means is, if you were to graph each of these lines, there's going to be some place where the two lines will intersect at a point. So line 2 is not perpendicular to line 1. As long as you know our little relationship about what to look for the slopes of perpendicular lines, you could just look at that and answer it without any work at all. These are great problems, aren't they? Okay, number 18. I'm again going to be given two lines. Line 1 and line 2 and I'm asked, are these two lines parallel or perpendicular or neither? Now, it's a trick question, because when you look at that equation is not written in y equals mx plus b form, nor is this one. So I don't know the slope of that line, and I don't know the slope of that line. But we can use our equation solving skills. Let's solve this equation for y. Let's get y by itself equals everything else, and then it'll be in slope-intercept form. Watch this. Subtract 2x from both sides of this, or add negative 2x. And that would give you negative 4y equals negative 2x plus 3. Okay? I just added negative 2x to both sides. Now see, I'm getting close. I have the y, I have the x, I have the constant term. I'm going to divide everything, both sides of the equation, this term, and this term, by negative 4. And that'll give me positive y. Negative 2 divided by negative 4 would be positive 1/2 x minus 3/4. Do you see how I divided each of these numbers by negative 4? So this is another way to write that equation, but it's in slope-intercept form. So what is the slope of line 1? M1 is equal to 1/2. Now, the moral of this story is, if you're ever asked to find the slope of a line and it's not written in slope-intercept form, this is always what you do. Solve that equation for y. Add the x term to both sides, divide by the coefficient of y, and now you know the slope of that line. Okay, let's do the same thing for line 2. Add negative 2x to both sides. That'll give you positive 4y equals negative 2x minus 3. Divide everything by 4. And that'll give you y equals negative 2 over 4 would be negative 1/2 x minus 3/4. You could write that as x over 2, negative x over 2, but you don't want to, because you want to look at that and you want it to be a coefficient times x, so that that coefficient is the slope of the line. So see, what you've determined is m2 is equal to negative 1/2. Now, are these lines perpendicular? No, because if a line was perpendicular to line 1, its slope, you take the negative reciprocal, and it would be negative 2. Are these lines parallel? No, because their slopes aren't the same thing. So, are these lines parallel, perpendicular, or neither? And the answer would be neither. Now that was a little bit harder, and you're going to have some like that on the homework, and you do them just like I did. If you'll read the text, he also has some examples where he works them out like this for you. Okay, let's look at some of the easier problems. Let's look at number 6. Number 6 says the slope of a line is 3/2. So I know the slope, let's call it line 1, is 3/2. The reason I keep calling something, M1 or L1, we always want to compare two lines. We want to know, are two different lines, line 1 or line 2, parallel, perpendicular, or neither? So if the slope of line 1 is 3/2, what is the slope of any line that's parallel to that? It also has to be 3/2. Okay? So the slope of any line parallel to M1 equals 3/2. Has the slope of 3/2. Question 8. Similar. That was number 6. Number 8, you're given that the slope of a line is negative 4/5. And you're asked, what is the slope of any line perpendicular? The slope of any line perpendicular is positive 5/4. It's going to be the negative reciprocal of that fraction. Just flip it upside down and change the sign. 5/4 is your answer. Let's look at number 10. You're given the equation of a line, and you're asked this question: is the graph of that line perpendicular to the graph of y equals negative 2? Okay. Is y equals 1/2 perpendicular to y equals negative 2? Are they perpendicular? Now, this is a classic trick question. You know what the easiest way to get your head straight on these? The problem is there an m in this, or an x term? There's no way to put that mx plus b when you first look at it. Likewise that. So anytime you see y equals a number, you just back off of formulas and everything else, and just think to yourself what we learned in class. We mentioned it a couple times. If you have y equals a constant, it's a horizontal line. It just runs through 1/2 on the y-axis. If you have y equals -2, it's a horizontal line. It runs through -2 on the y-axis. Well, let's graph it and look at it. 1, 2, -1, -2. Y equals 1/2 would be that line. And y equals -2 would be this line. So what are those lines? Parallel lines. This line is parallel to that one. Now, you just look at it and say, hey, horizontal lines, all horizontal lines are parallel. The same would be true about all vertical lines are parallel. Every vertical line is perpendicular to every horizontal line. And it's just nice to know those little tricks. Now, I'm going to show you something. It may confuse you, and if it does, just forget I said it. But if I were to take this equation and write it like this, y equals 0 times x plus 1/2. And I could do that because 0 times x would be 0, and 0 plus 1/2 would be 1/2, and I could be weird and write it that way if I wanted. If I wrote this equation, y equals 0 times x minus 2, I could do that. But if I write this one this way, doesn't that look like mx plus b? So m is 0. Over here, m is 0. These two lines have the same slope, and therefore they're parallel. Also, the slope of every horizontal line is 0, and that's why all horizontal lines are parallel. Their slopes are all the same thing. They're all 0. Let's do one more, number 12. Just like the last one, is the graph of this line parallel to the graph of that line? Well, let's do it like we did the last one. What kind of line, when you have x equals a constant, is it? Vertical line. It passes through 4 on the x-axis. 1, 2, 3, 4. Here's my line. There's x equals 4. What kind of line is x equals -4? Vertical line. It passes through -4. On the x-axis. Are these two lines parallel? Certainly they are. What is the slope of each of those lines? Ooh, this is a little weird. What is the slope of any vertical line? It's undefined. And so we can't say that one of these slopes is that these slopes are the same. Undefined may or may not equal undefined. But we're just going to say all vertical lines are parallel and let it go at that. Okay, let me, I'll have this on the website, but let's have you all do the following problems for homework, and you have this ready to go when you come to class on Wednesday, the 5th. On section 3.6, let's do numbers 5 through 29 odd. In our text. So that'll be your homework. Y'all have a great weekend and enjoy not having to come to class on Monday, but do the homework and get it all done. I'll see y'all, Lord willing, Wednesday when I get back. Or I'll see y'all Thursday when I get back, excuse me.